Welcome back to the videos regarding factoring. And now this is actually the fifth video, and the factor that we're going to be discussing here is factoring difference of two squares. Okay, so how does this look like? How would questions look like if we are to do or apply factoring difference of two squares? So let's have, for example, a squared minus b squared. So this is how the difference of two squares looks like. So again, the two terms of the binomial are perfect squares. So how do we find the factor of this kind of expression? So it's simply, you just get the square root of both of the terms. So of course we have two factors. So just write the square root of the two terms on both of the factors, and then one is minus and the other one is plus. Okay? So if you recall in the special products, when we have the sum and difference of a binomial, when we multiply it, our answer is just the square of the first and the square of the last. This is actually the reverse of it. So again, if you have e squared minus b squared, so both of the terms of the binomial are perfect squares, the factor would be just get the square root of the two terms of the given and then put that in the factor or inside the parenthesis. One is minus and the other one is plus. Okay, so let's practice this using examples. So let's factor completely. Let's have number one. Let's have 9x squared minus 1. Of course, the technique here is to identify if it's a perfect square. So if we look at 9x squared, that is, the square root of 9 is 3, and the square root of x squared is x. And 1 is a perfect square because 1 squared is simply 1. So therefore, our factor would be 3x minus 1 and 3x plus. Again, if we do apply the special products here, the answer will just be the product of the first and the product of the last, which will give us 9x squared minus 1. Okay, next, let's have another example. So let's have 4m squared minus 49. So again, let's identify first if there are perfect squares. So 4n squared, the square root of 4 is 2, the square root of n squared is n. So you can put it like this. And then 49 is 7 squared, right? So if we put that in our factors, then our factor would be 2n minus 7 and 2n plus 7. So again, it's just the same on the factors will be the same on both of the factors. But so the difference is just one is minus and the other one is plus. Okay. Next, let's have another example. Let's have this 180 n squared minus 5. So let's have to check. We have to check if both of the terms are perfect cubes. And in this case, 180 is not a perfect cube. Same as with 5. 5 is not a perfect cube. But if we look at 180 n squared and 5, they have a common factor, and that is 5. So what I can do is first, I will factor out 5. Okay? So common monomial is really something that's useful in terms of simplifying more a certain expression. So let's factor out 5. And if we divide 180 by 5, we will get 36. So we have here 36 m squared minus 1. And if you look at 36 m squared minus 1, we already know that these two terms are perfect squares. So 36, that's 6 m squared is m. So we can put it as 6m squared. And then 1 is simply 1 squared. It's a perfect square. So if we do that, we can now factor this one using the sum, or sorry, using the difference of two squares method. And don't forget to put the 5 here. And then we have 6m minus 1 and 6m plus 1. And these are now our answer. Okay, I did not box our final answer. These are all our answers. So again, if you have an expression as a difference of two squares, if the binomial has turned into a perfect squares, then this is the pattern that you need to follow. Just get the square roots of the terms and then plot them in the two factors. And then one factor has a minus operation or subtraction operation, and then the other one has an addition operation. Okay, so at this point, it's now your turn to practice. Okay, so let's practice. Factor completely the following. Again, if you feel that, for example, there's a given like in number 3 that it is not a perfect square, then just try to check if you can still use common monomial, or you can use other types of factoring first before you do the difference of two squares. So let's have 36 a to the fourth minus 25 125 n to the fourth minus 20 n to the fourth. And let's have 7x to the fourth minus 28. Okay. So at this point, I want you to pause the video so that you can answer on your own. You can always go back to the beginning of this video so that you can recall, and then you can just review or practice first with the examples that I gave. And then answer this practice exercise. Pause this video, and then afterwards, after you have finished answering the practice exercise, play again, press play again so that you can check if your answers are correct. Okay, so you can now pause the video. Okay, so let's now check if your answers are correct. So I hope that you find the questions challenging or easy as long as you're able to understand the concept of this factor. Okay, so let's answer this one. So 36 a to the fourth, I can express this as 6a squared squared. Okay. So I can express that as 6a squared squared. And this one as 5b squared squared. Right? So the factor would be 6a squared minus 5b squared and 6a squared plus 5b squared. Remember the loss of exponent? When an exponent is raised to another exponent, it multiplies. So here we have 125 and 20. And as you can see, 125 is not a perfect square, neither 20. So, but if we look at it, they have a common factor of 5. So let's try to bring out 5 first. So factor out 5, and then we'll get 25 n to the fourth minus 4 n to the fourth. And if you observe 25 n to the fourth and 4 n to the fourth are perfect squares already. So I'll just use a blue color. So 25 n to the fourth I can express as 5n squared squared, and 4n squared as 2n squared squared. So our factors would be 5n squared minus 2n squared times 5n squared plus 2n squared. But not forget the 5 that we factored out. Because if we don't put the 5 here, then we will not be able to get the given. Okay? Let's try the next one. Oh, looking at the third one, 7 and 28 are again not perfect squares. But 7 and 28 has a common factor, and that's actually 7. So let's factor out 7 first, and we will have x to the fourth. When we factor out 7, what will remain is x to the fourth minus 4y to the fourth. And here it is. There are perfect squares already. We can express it as x squared raised to the second power and 2y squared raised to the second power. Hence, our factors would be, do not forget the 7. So that's x squared minus 2y squared and x squared plus, oops, plus 2y squared. That's okay. So here are all our answers. This is our final answer for number 3, our final answer for number 2, and our final answer. And I hope you're able to get it correctly. If not, you can go back to view this video. If you want more activities regarding this, then you can just email me, or you can answer the activities. So I hope that you were able to understand that, and I'll see you on the next video.